All right, it's your choice, EIGRP or OSPF. Well, find out more about these different features in both routing protocols right here on IT Pro TV.
You're watching IT Pro TV.
We are taking a look at comparing routing concepts, and we're specifically focusing in on EIGRP and OSPF. And here to help us to know about those different features, Anthony Sequeira. Now, Anthony, we got to ask the overall question here. Which one do you prefer? The open source OSPF or, of course, the Cisco proprietary EIGRP? What is your favorite router or protocol?
Routing protocol, it really is OSPF.
Yeah.
It really is. And, you know, I love EIGRP for sure. It's just that I love OSPF better. And you know what's interesting? Kind of trivia, but EIGRP is now an open standard.
Yes.
Yeah.
And since 2013, if I remember
Yeah,
correctly. So it's
quite
been
a
a
while
while.
ago, right.
And yet, still in a lot of documentation, or I should say books, right?
Yeah.
They still say, no, it's Cisco proprietary.
Yeah. And thankfully, the question writers at Cisco would never ask that question.
Yes.
Because it would be a total trick question. So they'll drop that from your potential for quizzing because, you know, it's just unfair. There's so many students that don't realize Cisco opened up the code for open standard.
All right. So what are we really talking about when we're comparing? What features are we really looking at?
Yeah. Let's go through the feature list. And I started by expanding our discussion a little bit. I figured that our students wouldn't be mad at me if I did this. We are only, according to the blueprint, supposed to be discussing EIGRP and OSPF. But I wanted to start with just like, okay, what are our categories again? And this is controversial. That's why I wanted to start with it. I love this kind of stuff, right? Like, this really does cause controversy. Mm-hmm. You'll hear things like this. EIGRP is not a hybrid routing protocol. It's distance vector. You know, they're the link state people are mad that it's being called hybrid because they, you know, love to argue that it really doesn't have link state properties. Whatever. I don't engage in such things. I just know that what I put on this slide for us is what I believe to be true, and most importantly, what the exams would reflect. Your exams from Cisco are going to rightly consider, please note, all versions. I have heard students go, oh yeah, RIP, version 1's distance vector, version 2 is link state. It's like, no. You forgot that version 1 was classful and version 2 was classless. One time in life, it pays to be classless. And then, so RIP, distance vector, our link state, the big battle there is what's better, OSPF or ISIS? But both are link state. And then we have hybrid. It's a little bit of both, according to me, and Cisco's question authors. That's EIGRP. And BGP.
Right.
Have you heard this one? Path Vector Protocol? Mm-hmm. That's, okay, you've heard it. Cool. That's really what I think it falls best under. You'll see a lot of people try and pigeonhole that one to either like link state, distant vector. It really doesn't fit. It's its own unique animal. Now, with that review behind us, and that screen went black for a minute, and that was my transition. I thought my computer was flaking out on us. Anyways, now for the official kind of blueprint topics here, and they're very simple. What about load balancing? Well, with load balancing, both of our stars of the show in Encore, EIGRP and OSPF, both of them can do equal cost load balancing.
Right.
And both of them, you can control the number of links that will be load balanced across with the maximum hyphen path syntax at the CLI. So what do I want you to know out of this slide? Well, EIGRP permits something really cool. It's one of the real genius features of it, and that is that you can go in and do unequal cost path load balancing. And remember, it's the variance command. The variance command gives you a multiplier where you could go in and say, look, links 3 times as worse are allowed to be equal cost paths from a load balancing perspective. So that is very unique to EIGRP.
And it could also be potentially suboptimal, couldn't it?
Oh, yeah. You better be very careful when you configure that, because you could have, very inferior links being utilized, and you could have upset customers when you were really trying to make happy customers. Now, the algorithms used are very different in these two. So with EIGRP, we have something called the diffusing update algorithm, or DUAL. And I intentionally left all that blue space on this slide and did not put a graphic here, because if I see one more graphic of two people dueling with swords for EIGRP, I'm going to punch someone right in the face. All right, sorry. I have issues.
I think so. It's
Yeah.
pretty vocal about that.
So with EIGRP, it's the diffusing update algorithm. And the big unique thing about this is, the real one big thing, and it really is cool and impressive, is that there is this successor, the best way to get somewhere, and then feasible successors. And that really is neat. What it means is, when a primary path that was best goes away, there could be multiple paths standing at the ready to immediately be implemented as the new best path. I suppose the OSPF crowd, with their shortest path first, would go, who cares? Like, we converge so quickly that we don't need to do that stuff. But one thing I would like to say about the SPF algorithm is that, don't forget, how those link state routing protocols work is really neat. They're all creating, through shared information, their own map of the entire topology. And then they do that shortest path first calculation to give their best paths. And it's just really cool how everyone's working from their own generated view of the topo.
So, Anthony, I like this analogy that helps to understand if maybe it's been a while since people have come from their CCNA and they're trying to jump back in. So I've always, and I got dated by this because I said this one time in a classroom, like, what is that? So I used the idea of a road atlas. Okay, is that here it is? You live in one part of the state, I live in another part of the state, but you and I have the same road atlas. And if you say, hey, we're going to get to your home state of Massachusetts, we could both potentially take different paths, but that are best one for you. And I could take the best one for me, but we're working off that same database. And then the student said, all right, I get that, but what is a road atlas? Then I kind of said, never mind, we'll go and do something else. But I think that analogy actually does help people to kind of understand what we mean by that when we say, no, they share the entire routing table and they don't know why it makes sense to do so.
Yep, that's right. And another thing too, when we talk about these routing protocols, is that you can't forget, it really is true. The distance vector approach is routing by rumor.
Yeah.
It is routing by rumor. It's what your neighbor said is true. And we get in all kinds of problems with that. I think I've got one more comparison for you. Let's take a look at it. It's the metric.
Right.
EIGRP uses the craziest metric ever. It is some kooky stuff. We've got bandwidth, delay, reliability, load, and MTU. And MTU isn't really in the metric calculation. So why did I just mention it? Well, it factors in. It's really like a tiebreaker. And oh my gosh, Cisco gives us the reliability, the load, the band. They give us all these things. And then they tell us, oh, don't really change these too much because you can get all kinds of instabilities. So it's really an interesting metric situation there. Yeah,
there's no doubt that this is one of those where people always say, well, you get these K values, right? Or these K metrics, depending on, I think K values is. So when you get these, people are always like, why don't you actually manipulate the other ones? Because you're only really manipulating bandwidth or delay. But then you can show them like, well, here's why you don't manipulate reliability. And then you can show them the other one, which is essentially dynamically manipulated already. So in other words, really only those two are really the things that can influence the best.
That's absolutely right. And there's really only one case that you'd be manipulating the K values, and that is when you want to just override bandwidth. When you, for whatever reason, go, hey, EIGRP, let's make my call over bandwidth. I want traffic to go this way. Don't look at bandwidth. And in that regard, it's really cool. So this big, long, complex metric that they use does have benefit to us. Just remember this. If you're going to be using the K values to override the default decision of EIGRP unpathing, just remember, you're going to do that consistently.
Right.
You can't
All
just
routers.
visit a couple of routers and do those K values because EIGRP starts to really freak out. So what does OSPF use? Well, we probably know it's cost. Cost is based on one thing and one thing only, bandwidth. And this is important. Remember this. The cost based on bandwidth is with a formula, and you can manipulate that formula. What is it? Auto reference cost bandwidth or something?
Yeah.
It's a big long mouthful.
Yeah, I don't remember the actual command. for
Auto
it.
cost
Yeah.
reference bandwidth is what it is. And so you go in, you manipulate this value, Ronnie, and then it affects how the cost is calculated from
Right.
the actual bandwidth values. And again, there's only one time you would do this. If you're in a super fast environment, like 1 gig links, and then there's 10 gig
Right.
links, and there's 40 gig links. So that's the slowest you got is 1 gig. The rest are 10 gig, the rest are 40 gig. You would go in and you would manipulate the auto cost reference bandwidth because you want it to be able to see those as different. The default would just be like, oh, everything's fast. Everything's got the same cost.
Yeah, so that goes all the way back to where the fast Ethernet was kind of the original reference bandwidth. And remember, they had
Thank you.
kind of those original set values where it was like that was equal to 1
Yep,
and then
thank you.
10
Yep,
and stuff. But then when they
Spanning tree
modified
protocol
yep.
had the same problem,
Right,
right?
yeah.
It didn't think that there would be anything faster
Yeah.
than whatever speed at the time. Well, sure enough, they had to modify the standard to, accommodate these higher speeds. So
Yeah.
in OSPF, fortunately, we can override it ourselves.
Yeah, and it's necessary because there is a big difference between 1 gig and 40 gig links.
That's right.
But if we use those original values, well, you're not going to get a lower value than 1. So whether you're 1 gig, 10 gigs, 40 gigs, it all equals to 1. And that to OSPF would go, oh, no, they're equal cost overall. And you got to know that that's not true. So the ability for them to actually kind of change that and make that actually easier and manipulatable
Yep.
is probably actually a good thing.
It is a good thing. And, my gosh, I almost forgot to remind you of this. Don't forget, you can always go in to an interface in
Right.
OSPF and manipulate the cost. So you can always go in there and say IP OSPF cost and manipulate it. But what we're talking about is how fundamentally cost is arrived at.
Now, let me just bring a little bit of a side, kind of a tangent
sure.
for a
We
moment,
got
okay?
plenty of time.
So a lot of times when people start talking about like bandwidth, and they start talking about this idea of OSPF manipulating it, they don't get that difference between what the actual physical interface is actually doing versus the manipulation of the OSPF routing protocol itself.
Great
So
reminder.
they think like, well, if I change that, I'm going to make the data go a lot faster off that link. But that's not really true, right?
That's right. It's, the true bandwidth is what the interface is capable of. And that's going to be a maximum speed.
Yeah, and it's kind of neat. So some of the protocols like EIGRP, for example, right? In terms of the way that they exchange, we can take up just by default to 50% of that interface's bandwidth. And that's why you might want to choose some of those values carefully, especially when you start actually splitting that off. If not, you run into issues.
Ronnie, I had not thought about that in so long. That's another really cool thing about EIGRP that I got to tell you, I'd completely forgotten this. They designed EIGRP so it would be gentle and caring of that interface bandwidth, and it's preset to never saturate a link with its own traffic.
Yeah. All right. Well, Anthony, thank you again for helping us to review these concepts. That's easy to forget if you haven't been doing it for a while. Make sure you go back and review these simple notes that you have. And of course, there's more to this than you actually think as you continue to go on and do more and more advanced types of labbing, and you actually find it in real world situations as well. Well, that's going to actually do it for us in this episode. So signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
There is more to come on your next Cisco CCNP Encore show.
Thank you for watching IT Pro TV.